I'm Anil Kumar, and here's a practice test problem from Unit 2, Rate of Change, Advanced Functions, Grade 12. For the function f of x equals to 3x squared minus 2, find the equation for the slope of the secant line between any general point a f a and a plus h f of a plus h. Explain how this equation can help to determine both average and instantaneous rate of change at any given point on function f of x. Now this is a very important question. So before answering, let me explain you what this question is all about. So what I'll do is I'll just roughly sketch the function, which is 3x squared minus 2. So we have a vertical stretch and it's a parabola which is pulled 2 units down. So that means this is minus 2. Now we need to find equation for slope of a secant line between any general points, right? So that is to say that if I have a secant line joining any 2 points, so let me just join one line. Okay. Now it seems that the 2 points which I am looking for are this and this, correct? Now here, let us say the coordinates of this point are a. A is the x value, right? If a is the x value, then the y value is f of a. So that is what we mean, general point a, f of a, right? F of a is the y value for x value of a. The other coordinate point is slightly away from our point, so this is at this place, which we are saying is h units away. So the distance between these 2 points horizontally is h, right? So that means the coordinates of this point are, the x coordinate is a plus h since it is a units away, and the y coordinate is f of a plus h, right? So this point here will be f of a plus h, and this point here is a plus h units away from a, right? So when you join these 2 points, we get a secant, and slope of this secant gives you average rate of change between the 2 points, right? I hope the concept is clear. Now let us find an equation representing this, right? So we know average rate of change is equals to, between any 2 points we write b minus f of a over b minus a, right? In our case, our points are at a and a plus h, right? So the point b is a plus h, so we'll write this as f of a plus h minus f of a over a plus h minus a, right? Which can be simplified to the Venn-Lone difference quotient formula, right? So this is the difference quotient formula which you always use for finding rate of change, right? Now the function here is 3x squared minus 2. When I say f of a plus h, it means we have to replace the x value by a plus h, right? So now let us do that part. So the f of a plus h will be 3 times x is replaced by a plus h whole square minus 2. This is f of a plus h. Minus f of a means replace x with a. You get 3a square minus 2 divided by h, right? Now let us expand, right? So when you expand it, you get 3 times a square plus 2ah plus h square minus 2, and the second term is 3a square minus 2 divided by h. Now look at it very carefully. These 2 terms, 3a square, 3 times a square will be 3 square. So 3a square minus 3a square will be 0. So I can kind of cancel it, right? Minus 2 and minus 2 cancels, right? So now I can simplify this and I can write it as 3 times 2, which is 6AH plus 3H square divided by H. Now dividing by H is common factor here. What do we get? We get 6A plus 3H. So that becomes the average rate of change at any point A, right? Between any 2 points, starting from A and the other point is H units away from A. Do you see that? Correct. Now, the question is, explain how this equation can help to determine both average and instantaneous rate of change at any given point on the function. Now, average is clear to you. If I say, now let me take a concrete example. So we are saying that the average rate of change, let me use the symbol, equals to 6A plus 3H. Correct? Now, if let us say the 2 points are at x equals to, let us say 1, and let us say H is equal to, let us say also 1. Okay, that means we are taking a point, that means our interval is from 1 to 2. Do you see that? In that case, the average rate of change will be, if I substitute 1 for both, I get 6 times 1 plus 3 times 1, which is 9. So that is the average rate of change. But if I want instantaneous rate of change, then what should I do? If I want instantaneous rate of change, in that case, I'm looking for a point which is very, very close. So we say, well, let H approach 0. Correct? And then we'll find what is instantaneous rate of change at x equals to 1. Now, if H is approaching 0, then instantaneous rate of change at 1 will be 6. You get the point? Right? So that is how we can find instantaneous rate of change. Now, you remember, always we say estimate. So let me now throw some light on this part also. Estimate. What does this mean? Always we'll say instantaneous rate of change is estimated. Right? So that means we cannot really be at one point. The other point has to be slightly away. Okay? And let us say that the value of H is 0.01. In that case, we are estimating our answer to 2 decimal places. I hope you appreciate that. So now let us estimate instantaneous rate of change at x equals to 1. Then what will it be? It will be equal to 6 times 1 plus 3 times 0.01. Do you see that? So it becomes 6.03. So that is accurate to 2 decimal places. If I have to estimate to 3 decimal places, I will use value of H as 0.001. That is very critical for you to understand, right? And if I am trying to be, exact kind of, right? I see H is approaching 0, so I just forget about it altogether, and then I say, well, it approaches 6 as H value is decreased. It becomes 0.00001. This becomes 6.00003, right? Which is approaching 6. Since the slope of the secant is approaching 6, we say that the slope for the tangent is 6, and therefore the instantaneous rate of change at 1 for this given function is 6. I hope that makes things absolutely clear. I'll prefer, and I would like you to watch this video again so that you understand this concept and then move on with rate of change. I hope that helps. Thank you and all the best.